a quick look. Okay, similar to before, apart from maybe some of the wording kind of threw you off a bit. We're going to do the journey in two different ways. We're going to journey from O to X, first of all. Maybe I'll do that working out down here. In fact, I might just shrink this question down. We're going to do the journey O to X to start with. O to X is some multiple of O to C. This time we don't know what that multiple is going to be. O to C, though, to go from O to C, I'm going to do this little extra bit of working out up here. To go from O to C is A plus B, because you go along A and then you add on B. So it's lambda lots of A plus B, which is lambda A plus lambda B. Now, a few people were making a mistake in this second part. They were working out what the question said, which was Bx, but they were forgetting that eventually you have to work out what Ox is, okay? So I'm going to start off by working out what the question said, which is what Bx is. And they've told us that we're going to say that Bx is some fraction of Bq. Okay, well, I better work out what Bq is. Now, I'm not going to do Q minus B. I'm going to look at the diagram. To go from B to Q, I'm minusing B plus a third A. So that's minus B plus a third A. So to go from B to X, it is mu lots of minus B plus a third A, which is minus mu B plus a third mu A. This is where many people made a mistake. They were like, cool, this thing and this thing are equal to each other. How do I know they're definitely not equal to each other? It doesn't look like this one's OX and this one's BX. They're obviously not equal to each other. They're describing different pathways. Okay? So I need to do a bit more work on this. I need to say what OX is equal to. To go from O to X, I'm going to do OB plus BX. So it's just going to be B plus BX. That's why they asked you to work out what BX is, so you can use it in this question. So it becomes B minus mu B plus a third mu A. If I factorize out the B, I get 1 minus mu B plus a third mu A. That is what OX is equal to. Now I can do part C of the question, which says comparing coefficients. So if I compare, I'm going to compare OX and OX with each other. So I get lambda A plus lambda B equals, I'm just going to write this bit first actually. No, I'll do the same. 1 minus mu B plus a third mu A. You can then see lambda, which goes with the A, is equal to a third mu. And also lambda is equal to 1 minus mu that goes with the B. So you get lambda is 1 minus mu, and lambda is equal to a third mu. Solving these simultaneously, I get 1 minus mu is equal to a third mu. So 1 is 4/3 mu. So mu is 3/4, which means that lambda is 1/4.
And then you find all C.
Yeah, we haven't quite done this. So now they've said that lambda is a quarter. That's the thing that they wanted. Lambda was describing this journey here. So to go from O to X, that bit there is 1/4. That bit there must be 3/4. So the ratio of OX to XC is 1/4 to 3/4, which is 1 to 3. Okay? This isn't easy, and if you know that you found this hard, what you're going to need to do is go back and watch this again and make sure that you can do it completely independently of my notes, okay? Otherwise, just sitting there and thinking, yeah, okay, I understand it, is not good enough. It's not going to stick in your mind, and you're going to feel underprepared for when these kind of questions come across, okay? So the next part that we do is we do this again, but we start doing it in 3 dimensions. But the idea is exactly the same thing. We're going to use that strategy of tracing out the pathway in 2 different ways, and we're going to use lambda and mu to describe those pathways that we have here. If you're finding this challenging, I'm not surprised. This is a challenging kind of topic. There's a couple of tips I would give you. Do you notice every time I write the letter A and the letter B, I underline it? You should do that because it will make the algebra look less messy. There's almost no numbers on this page, which makes our brains, it's like kind of like overload of all the things we're looking at. If you can get into the habit of underlining A and B, you will start to see them as something slightly different to the rest of the algebra, and it will feel less busy. Okay, so try and do the things that I do and the way I follow stuff, because it should be helpful for you. Okay, there is this tiny little question that probably you haven't had a quick look at, but it's just to show that you can compare coefficients. I don't think we even really need to do it. You can see very clearly they're telling us these two things are equal to each other. Clearly, P is equal to 3, P plus 2 is equal to minus Q, and 120 is equal to 4PQR. So you could just solve those equations to find out what P, Q, and R are. There's nothing, I don't think, that we even really need to do there. I just am worried we're going to run out of a bit of time, and I want you to have some practice. Okay, so this one again is going to follow the same idea. The diagram shows a cuboid whose vertices are blah, 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 blah. With a cuboid or three-dimensional shapes, we can't describe the pathway that you take around the outside like you do with a two-dimensional shape. With a 2D shape, when I said it was PQRS, that had to go around the outside of the shape. In 3 dimensions, that's a bit more tricky because how do you describe what pathway that you're going to take? Are you going to go around the bottom and then you're going to go up the side and then, it's a bit, how do you describe which path you take? And it says vectors A, B, and C are the position vectors of the vertices A, B, and C. So that's the vector A, that's the vector B, and that's the vector C. Can anybody tell me then what would be the vector GE? Pardon? Yeah, it would be B because it's going to be parallel to this side that we've got here. And the vector FE? What about GC? Minus A, good. Okay, so we now know all of the sides of what the cuboid should be in terms of their vectors. Prove that the diagonals OE and BG bisect each other. We've got that word bisect again, which is going to say cut in half. Now we're trying to prove about these two diagonals. I've added these diagonals onto the diagram. If you ever get given a diagram and they're talking to you about the diagonals, you should add them on. These diagonals are going from one corner of the box to the other corner of the box, and vice versa with this orange one that we have here, okay? Let's do the same strategy. So we're going to try and get to, I've called it H, we're going to try and get to that H point in 2 different journeys. The first journey that I'm going to do, I'll do it in blue, seeing as it's already in this journey colour here. I'm going to try and work out the vector OH by going some fraction of the way along the line OE. Okay, well, it looks like I better work out what OE is equal to. What's OE equal to? A plus B plus C. Okay, so OE is A plus B plus C. So now we've got that OH is all of that multiplied by lambda. So that's lambda A plus lambda B plus lambda C. That's the easy one. Right, let's now do this darker one. Is this orange? Yeah, that's going to be for our orangey pathway that we've got here. We're going to try and use this part of the pathway, and I'm also going to use this side of it as well. If I can travel from O to B and then some way along BG, and if I can show that the H is in the same point for both of them, and I find the value of lambda and mu, I'm again going to show that they intersect each other and hopefully that they bisect as a half. So if I want to go from O to H in a different journey, to go from O to H, I'm going to go from O to B, which is just B, plus B to H. So if I want to go, not BH, sorry, I want to go some distance of the way along BG. I'm going to use mu, and I'm going to go somewhere along BG. Well, we better work out what BG is, because we're going to need that. How do you go from B to G? Careful.
Oh, sorry. Minus B plus A plus C.
Good. It is minus B plus A plus C, because you're going to go backwards along the B, along A, and you're going to go up, which is C. No, because actually, if you think about it as doing it as A minus B, C, that is going A along the back, minus B to come up to A, and then plus C. You could equally have gone up straight away. You could have done C, A minus B. Any way, you'll still end up at the same point, okay? In fact, the different orders you do those represent all of the different possible pathways you can take anyway. So there's 6 different pathways you could take. Is that right? Yeah, 1, 2, 3, 4, 5, 6, yeah. So OH this time is B plus mu lots of all of this. So that's going to be, let's just write that out, minus B plus A plus C. So that's B minus mu B plus mu A plus mu C. What do you think's sensible that I should do on my OH here? Do what to it, sorry? Yeah, factorise it. So I'm going to factorise this by B. I like to put it afterwards. So I've got 1 minus mu B plus mu A plus mu C. Now I get to part C of our question, which is to do the comparing coefficients. So let's compare coefficients. Save a bit of time there. We know that OH is equal to OH. So this thing has got to be equal to this thing. So lambda A plus lambda B plus lambda C is equal to 1 minus mu B plus mu A plus mu C. Tells me 3 things. Lambda is equal to mu. Lambda is equal to 1 minus mu. Lambda is equal to mu. So we've really only actually got 2 equations here. Lambda is mu, and lambda is 1 minus mu, which is the same simultaneous equations that we had before. So we get mu equals 1 minus mu, 2 mu is 1, mu is a half, lambda is a half. So the diagonals bisect, because it's a half. Okay. Now, with this question, do you notice how it's basically the same question that we just did? The maths is nearly identical, apart from there was this extra C that had been added on. That's the only thing that's different. What do you think would be a condition in this algebra down here if we were talking about and we were trying to prove that 2 diagonals did not intersect each other? What could go wrong if we got... There could be another, you might have another equation here, and maybe it would say something different. It might have said, I don't know, maybe this would be like 3c. So you get lambda equals 3, lambda equals mu, and this thing here. So you might get 3 pairs of equations that don't have a solution. So if you can't make the A's, the B's, and the C's all equal to each other, then it shows they don't intersect. There's no place where they all meet, so it makes it true. Just in case they would do something a bit of a twist, they might say, prove that these 2 things do not intersect each other. You could then do the question as normal, thinking that they're going to intersect, and go like, uh-oh, there's no solution to the simultaneous equation. Or you get something like 0 equals 1, which means that it's obviously not going to be an intersection. Okay, so there's only one question that's like this in the exercise, so I'm going to just quickly have a look at that now and tell you which ones that I want you to do. We've still got enough time to do this.